Today's lecture is in honor of Cliff Clogg, one of the leading researchers who's working at the intersection of sociology or social science and statistics. Professor Clogg was a faculty member in sociology and statistics at Penn State, and he made numerous contributions to both disciplines and was particularly well known for his research in demography, latent class models, and categorical data analysis. We are honored that Professor Clogg's wife, Judy Clogg, is here with us today. Welcome, Judy. And I believe their 4 children should hopefully have found the Zoom link and are also in attendance from various parts of the country. The list of speakers for the Clogg Lectureship reads like a who's who of researchers who have worked at the intersection of statistics and sociology. And you can find the list online, but a few examples are Bob Groves. Some of you may have heard of him in association with the census. Steve Feinberg, Susan Murphy, Adrian Raftery, Don Rubin, and Gary King. And if I picked the other list of names, they would have been just as famous as the ones I picked here, among others. So with that, I'd like to now introduce the 19th in that distinguished list of speakers, our 2022 Clogg lecturer. It's interesting because he's also the 2020 Clogg lecturer. but
COVID.
We had a pandemic, so some of you know. And so Professor Jerry Reiter is currently interim dean of the natural sciences and professor of statistics at Duke University. He has a PhD in statistics from Harvard. He's been on the faculty at Duke for exactly 20 years. So I don't have to say about a couple of decades, it's exactly 2 decades. His research focuses on applied and methodological research in statistics with a heavy emphasis on solving problems in social science and public policy. So he's really an ideal recipient for this award. He's well known for his research in statistical methods for handling missing data, for methods for protecting data confidentiality, and in particular for the area of imputation, multiple imputation. He's a fellow of the Institute of Mathematical Statistics and the American Statistical Association. He's won numerous other accolades. He's been active in leadership roles, most recently as chair and dean, but also as leader of the Triangle Census Research Network in North Carolina and the Information Initiative at Duke. In addition to his research accolades and major leadership roles, he's received a lot of awards for his teaching and mentoring. And I'll just speak about one really notable one, which is the Alumni Distinguished Undergraduate Teaching Award at Duke, which is really an equivalent to that is Undergraduate Teacher of the Year, which is according to Duke students. So it's an award given by the students. And in addition to the public lecture today, he will give a more technical talk tomorrow from 11 a.m. to noon in 102 Thomas Building. This is 201. That's 102. Good mind. Just downstairs from here. We are really delighted to have him here at Penn State. Please join me in welcoming Jerry as a 2022 Cliff Clogg lecturer.
Thank you very much. Well, thank you very much. Thank you, Emily, for the kind introduction, and thank you all for honoring me with the Clifford Clogg Memorial Lecture Award. I actually first encountered Professor Clogg's research works when I was a PhD student at Harvard, and I should stay over here with the Zoom. I tend to wander. And one particular paper that I have a very vivid memory of, it was a project that involved what's called occupational recodes for the census, where they had basically an old coding system for business establishments, for occupations, and then a new coding system, and how are they going to make the crosswalk? And so the Census Bureau went ahead and basically got a sample of certain individuals where they could make that crosswalk, and then from that build models that would essentially predict what the new code was given the old code and use those models to impute plausible values of the new codes. Okay? And that actually struck me quite a bit. And as I look back on my research career, oh my gosh, this is like exactly what I've been doing. Imputation of missing data, where you're looking to do data fusion to create a public use database with a Census Bureau data product. Like you can write the description of my career, it's essentially what Professor Clogg did in that. So it is deeply, deeply honoring to be able to deliver these lectures and recognize the impact that he had on my career as many others. So I'm not going to talk about missing data today, that's tomorrow, but what I do want to talk about is this question right here. Is there a future for public use data? And I'm going to sort of betray the fact that I want the answer to be yes, and I suspect many of you also want the answer to be yes. But I want to tell you, what some of the potential worries are that the answer might not be yes, and then tell you sort of my own thoughts, vision, if you will, about how we might get to a yes on this question. And along the way, I will talk about some of the strategies that statistical agencies, other organizations. I mostly focus on statistical agencies. I've worked a lot with the federal government. I'm actually a part-time employee of the Census Bureau. Anything I say here is not the opinions of me and not the opinions of the Census Bureau. But review a little bit what they've done and give you some, like I said, some paths that I think might be ways forward. So why do I want the answer to be yes? Well, there are people out there, there is a sense out there that maybe the answer should be no, that we shouldn't be giving out public use data anymore, that people should be just querying systems to get answers to particular statistical inquiries, and that's it. You don't have data for the public. You might have data if you have special sworn status or something, but the public wouldn't have data. And I think record level data, individual level data are enormously beneficial for society. And here are some reasons, right? I mean, the most obvious one, of course, is the one that a lot of us care about, which it facilitates research and policy making, right? I think it's quite difficult to get a sense as to how to analyze a particular policy question, how to state a particular policy question for that matter, without having some data in front of you, right? It also trains students in the skills of data analysis. If we want students to go on to be experts in evidence-based policy making, we need them training on social science and policy type databases and not, and I will attack not just statistics, which I love, but we need social science databases for people to train on. For those of us who like to develop new methods, right? I mean, if you have a real or realistic, for that matter, data to develop your methods on, that's really important, right? That's really, really important. And lastly, and this is, I don't think should be underestimated, citizens who aren't necessarily in academia or a research organization, they want to understand their communities too. Where should we build this school? What are the associations between education attainment and other variables? And so I think it's really important that we find ways to create public use data. Of course, the tricky part here, the reason why I'm up here, is because agencies, and when I say agencies, I mean broadly any organization that's seeking to share data, but if you want, you can think of it as a government agency. They are ethically and sometimes legally obligated to protect data subjects' privacy and confidentiality. And in particular, there's a strong societal demand for privacy, and so we can't just disregard that. So agencies have known about this for a long time, and so in the beginning there was this sense of, well, if we just anonymize the data, if we just take off the names and the addresses and the social security numbers, that should be enough, right? I mean, how can you re-identify somebody if you don't have their name? Well, unfortunately, what we're learning is that the answer to this question is probably no in a lot of cases. Anonymization is not enough. It's necessary, but it's not sufficient, right? And here's a couple of examples here, very famous ones. This is kind of the first paper on my left, on your left, sorry, is the paper that started a lot of this off, written by Latanya Sweeney. She is a computer scientist. She was a PhD student at the time at MIT. And what she did was got some anonymized data, health data, from basically from Massachusetts. Okay, and they said, yeah, sure, you can have it. It's fine. It's anonymized. And what she did was she went to voter registration files, which you can get, right? You can. Some states you can pay for, others you can just have for free. And she went ahead and those rolls, they have, they'll have a name and they'll have a zip code, right? And something about age. And then she matched on those variables to this anonymized health file and was then able to identify Governor William Weld, whose name some of you may recognize has been a recent libertarian candidate for president, right? So this is a big deal, right? The supposedly anonymized data, nope. More recently, so Latanya did that back in the late 90s. More recently, Arvind Narayan and Vitaly Shmatakov, they went ahead and took a data set that was made available by the company Netflix, data set with movie ratings. And they run one of these challenges, right? One of these hackathon type things where it's really smart, right? Companies do this. They put out these data sets. They run this challenge. Build your best predictor of which movies a person will like given what we tell you about them. And it's smart because then they get a whole bunch of algorithms for far cheaper than they could ever possibly imagine getting if they hired enough employees to do this, right? So it's a really great idea. So they put out these anonymized movie ratings, and they actually stripped off a few other variables and their little perturbations as well. And what these two computer scientists did was they said, you know what, just for fun, let's go to the IMDb public movie ratings data, because a lot of people like to go online and say, I like this movie and I like that movie too. And they were able to link the movie watching pattern in the IMDb database for an individual to this anonymized Netflix data set. And then they were able to learn some of the information that was in the Netflix data set, like political affiliation and things like this. And so they took it down. Netflix took it down, and it was a big deal. And there are a bunch of these kinds of examples that we know of. There may be more that we don't know of, and that's really kind of one of the fears, beyond just computer scientists having fun, worries about companies doing this to mine health data to identify bad credit bets, even though that's illegal. Who knows, right? Or you can imagine nosy neighbors wondering, what their neighbor wrote. They know they're in the survey. I'm wondering what they wrote down for their income, or an employer, wondering what their employee wrote down for their satisfaction, or a parent wondering what their kid answered on a drug survey. You can imagine a lot of these sorts of things where you might worry about these kind of identifications. So anonymization, unfortunately, is not enough. Now, agencies have recognized this, and so most agencies will fuzz up the data, will mess with the data before they disseminate it. So if you go to a government agency website and you download a data set, you are not getting the raw data. You are getting the data that is passed through some agency-determined filter for privacy, also for other things like missing data and editing. That's another story. But it's passed through some privacy filter to try to reduce these risks of these unintended disclosures. And these are some common techniques. I'll just quickly go through them so you can have a sense of what the landscape looks like. So the most common one is called aggregation, right? And you've probably seen this, right? You won't get an address down to the street number and things like that, right? You might not even get it to the block, right? You might get it to a metropolitan statistical area, at least 100,000 people, or HIPAA says there must be at least 20,000 in their safe harbor rules for releasing data. So coarsening geography, top coding, if you have incomes, just chop it off 100,000 or more, or chop it off the other way, 10,000 or less. You can imagine there are these top code and bottom codes, collapsing categories to coarsen, very common. The idea here, the hope is that without providing this high level of detail, by aggregating it up, you create individuals that look similar to each other, right, as opposed to looking unique. Data suppression, just blanking data, basically, right? This is very common with tabular data. You may have downloaded data sets, and you see little asterisks all over the place where cells have been deleted in the data set. I've seen data products where this is done to such an extreme that more than half of the cells are suppressed, right? And I'm not sure what you're analyzing at that point. But that's very common. Swapping, this is really interesting. This is what the Census Bureau used and what's caused all the controversy around the 2020 disclosure avoidance changes. Those of you who might be familiar with that, I'm happy to talk about that in questions. But swapping basically takes one record's data and switches them with another record's data. Of course, they don't tell you which records were swapped. But the idea there is that if some adversary, some intruder comes along and says, I identified Jerry, well, the agency could say, well, maybe that wasn't Jerry, because it might have been swapped, right? So it's protection by perception in some ways. By the way, none of us know what the swap rate is for the 2010 census and earlier. Okay, that's not public information. In fact, the director of the Census Bureau does not know that information. And that's just in case she or he or they are ever called in front of Congress, they can plausibly deny that they know the swap rate. Why anybody would have to plausibly deny they know the swap rate for the decennial census in front of Congress, I don't know. But they have that ability. So we all think it's low. We all think it's like low, right? Because if it's high, correlations across variables swapped and unswapped are going to really be attenuated, and that could create all sorts of problems. Adding random noise is another one where you take a value and just add some noise to it, maybe from some Gaussian distribution, normal distribution. Maybe there's a hole in the middle to make sure the value that you've added is at least a certain distance away. There are various noise ideas. These are commonly used all the time. And the problem with these, or the limitation of these, I guess, if you think about applying these with really high intensity, you can imagine this is going to really hurt the quality of the data. Right? Think about suppression. Like I said, some of these transportation tables, for example, they blank all the cells where there's only like less than 3 people that bike to work more than 10 miles or whatever. So they blank all these cells. And you see in these big transportation files that they get that huge fractions of the data are blanked, and the transportation researchers basically say, we can't use this. This is not usable, right? So massive suppression could create also problems, not to mention selection biases if you suppress values that are large, right? We all know not ignorable missing data, to make a little ad for tomorrow's talk. Swapping, we talked about that. Imagine if you swapped 100% of the values. I mean, there'd be no association between the variables that were swapped and unswapped. Adding random noise, think about having a tail like income, right, where there's a tail, and you have some large values. You might have to add a pretty substantial amount of noise to move those away from their original values so you can disguise those people. And if Bill Gates is in your data set and you've got to add noise, you're not adding noise mean 0, variance 1,000. You're not adding noise mean 0, variance 1,000,000. You're probably adding noise mean 0, variance 1,000,000,000. And that's going to do a few things to the rest of the data, right? So it's high intensity really can cause problems. So that's why they've tended to be very low intensity. That's historically what it's been. But now what we're worried about, just like these examples from the last slide, that these low intensity perturbations are just not sufficiently protective, right? So think about a swap rate. Again, we don't know what they are, but we all think it's like, was like 1% or something, or less maybe. 1% of values were swapped. But what that means, say it is, I'm guessing, just to be really clear. Say it is 1%. That means 99% of the records are not swapped. That means if somebody is trying to like re-identify individuals in the census to learn stuff about them, there's a 99% chance that they might be right. Okay, so again, protection by perception, right? So low intensity perturbations, we worry more and more that they're not protective, and the computer science community has come up with lots and lots of examples. So what are we going to do? Okay, what are we going to do? Okay, well, this is the idea that I've done a lot of research on, and I think has some promise here. It's not, it's not without its challenges, but it has to do what's called synthetic data. This was an idea proposed by Don Rubin in 1993. Don happens to be my PhD advisor, although my PhD had absolutely nothing to do with synthetic data, but it was related to government, a government agency problem. But basically the idea is to take the data that's been collected, fit some kind of model to the data, and then simulate new records from that model, and release the simulated data as public use files. Okay? And if we can do that well, and that is a huge if, I'm going to put capital letters on that. If we can do that well, there's a lot of potential advantages, right? Because first of all, this is not Jerry. This is a simulated record. So those kind of linkage attacks that I talked about with LaTanya Sweeney and the two computer scientists from UT Dallas, those attacks don't really make sense. I mean, somebody could do it, but what are they linking to? They're linking to a simulated record. Right? So we should have low risks. That's not to say zero, because that's one thing we've learned is there are risks. And you can imagine, if you have a model for generating data and it's like, it gives you an R squared of 0.999 just to be extreme, maybe that's a risk, right? If it always reproduces an actual data value, maybe that's a risk. The agency has to decide that. So that's why we say low risk, if we can do it well. Also, if we can do it well, we have potential here, right? We might be able to sort of preserve associations, keep tails, enable estimation at smaller geographic levels. So there's a lot of potential for this. It's actually being done. So the Census Bureau has some synthetic data files. There's the Synthetic Longitudinal Business Database. This is a product that I actually was involved with and supervised the creation of. I'm going to talk a little bit about it. The Synthetic Survey of Income and Program Participation, the SIP. The SIP is the largest database of people on public assistance in the U.S., survey anyway. And they actually, some economists at Cornell combined Social Security earnings and disability payments to these people that were in the SIP. And it's really cool, right? Because you can imagine if you had earnings history and you have these, SIP has like exact timings of when people go on and off public assistance. So that's really rich, right? Then you could start to do some very interesting modeling. But as Social Security said, you can't release people's incomes. We're not going to let you do that. And so they made a synthetic data set. And you can go analyze that data, go download it from the Census Bureau website right now. American Community Survey, group quarters data. Group quarters are people who live in dormitories, shelters, prisons. And they're very identified because there's only one, say, prison in a particular area, right? And so if you release that they're in the prison, it kind of narrows things down pretty quickly. So they wound up like synthesizing basically a lot of the identifying variables like their age and education and things like that. ACS is trying to make synthetic data bigger now for the whole thing. I'm part of that project. On the map, this is a really cool application. This is you can do maps of street blocks where people live and go to work. And the street block of where they go to work is fixed, it's their actual, and the street block of where they live is simulated, some big multinomial kind of distribution that simulates where they live. So you can get these maps that people can use for transportation planning or disaster planning, and it's all partially simulated, which is pretty neat. Other countries are doing this too. So it's catching on, actually. Let me tell you a little bit about the LBD, just to give you a flavor that, this actually might work. This can be done. So the LBD, I don't know if any of you work with this. This is kind of the go-to database for people who study productivity. Okay, so it's a census. It basically comes from tax files, businesses, And people use it to see how much their jobs are changing from one year to the next in particular industries and things like that. The data that I had, it started in 1976. That is the start year. It keeps going every year. The data that I had, that I'll show you, we had up to, I think it's 2015 at this point. There were about 30 million, more than 30 million establishments. That's obviously gone up. The real issue, though, is that these data are super protected. Because they come from tax data, they're subject to two regs, which is Title 13 and Title 26. Title 13 is the Census Bureau's reg. It basically says, Census Bureau, you can't release anything that leads to a re-identification. Okay? Title 26 is the tax data law, which that one's even more strict. That one says you can't even release the fact that an establishment is in this database. Like, you can imagine why. Did you file taxes or not? You can imagine why that law is very strict, right? So, so the only way there's no public use database for this, but Census wanted to create one, and the only way that they were willing to do it is if we made a synthetic version, like all the other stuff, the kind of traditional disclosure control techniques I summarized. They just weren't going to work for this problem. So these are the variables. I'm not going to go through this in detail, but just to let you know that everything ranging from, well, X's are kind of the location and the industry code. We actually fixed those because it turns out that information is publicly available already. The Census Bureau already releases all that, so we decided, well, it's already there, so knowing that there's a big airplane manufacturer in Washington is not a surprise. But we synthesized everything else, like when the establishment came into existence, when it went out, longitudinal histories, that's what the T's are for. Is it part of a firm, like your local McDonald's is part of a firm McDonald's? Is it, well, how many employees, what's the payroll? All this stuff. So it doesn't look like a lot of variables, but over 30, some odd years, it adds up. Okay, and I won't get into the modeling strategy just for time, but if you're curious, I can tell you more. Okay, but let me just basically tell you, it's basically a bunch of regressions that we just chain together. That's the idea. Let me give you some results that just to convince you that this synthetic data idea is not crazy. I mean, it sounds crazy. People actually, when Don Rubin proposed it, people said you're crazy. But 20 years later, 30 years later, it's being investigated pretty seriously. Job destruction rates. So this is how many jobs were lost from one year to the next. Okay, so 2011, sorry, it was last year on this plot. And you can see that, apologies for the colors, for those who can't see the colors. There's the LBD one, which starts at that very top. Let's see, I think there's a pointer here. That one, that's the LBD, and you can kind of follow that line. Then there's two implicates that start there, two separate runs of this, basically, because we wanted to see if it varied a lot. And overall, you can see that we track the results from the real data pretty well. We miss sometimes. It's not perfect, right? We kind of miss that. We thought there was a bigger bump there and there, too. But overall, I think researchers could learn a lot from this completely synthetic file about job destructions. This was even more complicated. This is weighted establishment acquisition events. What's that? So that's when one company acquires an establishment, and weighted means it's like inflated. It's counted by the number of employees that get acquired. So this is a really complicated thing. We did not set out to simulate this at all. This is a function of employment and are you part of a firm, really. That's what it's a function of, which we simulated. And again, you can see we do remarkably well, right? We're capturing the trend. We're not perfect. We're not perfect. It's going to be biases. This kind of gigantic data set, any little bias gets magnified enormously. Okay, but overall, I think it's pretty useful. Divestiture events. This is another one, very common. This is basically like, did they get rid of a company, right? That's the opposite of acquiring. And you can see, again, this one we didn't do quite as well on, right? So you can see some of these bars. We missed the big spikes. The bigger spikes are the actual LBD, and to the right is one of the synthetic data implicates. So you can see that we missed some of those big spikes. It's not going to be perfect. And I think that's one of the messages I wanted to take home from this is that, these synthetic data, they could be quite useful for lots of analyses, but they're not going to be perfect. And anybody who tries to tell you that they're perfect is trying to sell you, right? So, in fact, whatever we put into the model is going to be put into the synthetic data. So if we assume something has a normal distribution, but it really doesn't, well, guess what? Our synthetic data are going to look like a normal distribution, but the real data didn't. So we're going to, if we want to learn about the tails or something, we're going to be off. Maybe the mean will be fine, but if we want to learn about the tails, we might be off, right? So this is the concern that everyone has justifiably with synthetic data, which is that basically whatever the quality of the synthesis models is pretty much the quality of the analysis. I mean, that's really what it comes down to. Okay, and that is correct. We can't preserve everything. Otherwise, you have the original data again. Right? In the real world, you can't preserve everything. In a simulation, you can, but in the real world, you cannot. Okay? So what do we do? What do we do for this problem? So that's stage one. Like, I think this idea of making synthetic data sets to try to deal with some of the privacy risks has a lot of potential. Okay? Here's step two. So this concern about are the synthetic data good enough for what I want to do, that's really important. But we need to give people a means to assess that for their particular analysis, right? Because I showed you a few, but there's an infinite number more that somebody could want to do. And so what we've been working on, and this goes back to a paper that I proposed, and probably other people before me, Stigler's law thought of this, is a verification server. So this is basically it's a computer system that's got the synthetic or otherwise redacted data, and it's got the confidential data. So it has both. The user, she has only the synthetic data, right? But the system has both. And the user, she submits a query to the system, says, oh, hey, I want to do a regression of variable 1 and variable 812 and the log of variable 24. And the server computes some measure of similarity, how much of the confidence intervals overlap. I can't do that. How far apart are the point estimates. You can imagine lots of similarity measures that might be useful. And the user, they report that back, and the user can decide if the synthetic data are good enough, published in the broad sense. Maybe they are, but maybe they're not. And I'll talk about that. The trick here, the hard part, is that these quality measures actually leak information about the data. And someone who's clever might be able to submit certain queries to triangulate and learn some sensitive information. Okay, so that's really the concern. So we really have to kind of fuzz up these quality measures as well. And that turns out to be actually more challenging to do in a quality way than it sounds. Okay, but that's the trick. So here's kind of the way I want to put this together. What I want to do, okay, so this is what I've sort of been pushing a lot of my research agenda towards, is this, a vision for data access. Okay, maybe that sounds too lofty. But build an integrated system that's got synthetic data. That's a public use data file. So all of us in this room could start with it, right? Analyze, do whatever we want, build code, etc. Then also give people access to the confidential data through remote access, through they're trusted. Trusted is not the greatest word. They've been vetted, they're approved to get access to the confidential data, so they could do that. But then gluing these two together is that verification server idea, right? Sitting in the middle between those two. And I like this idea of all three of these in one system, because what can we do? So the user can start with the synthetic data, right? And she can develop code, explore the data, determine what the right questions are. Are there enough individuals of this particular group to support the kind of analysis that I want to do? Right? Having some synthetic data might help them decide whether that's true or not. Write your code, decide if you need to do certain transformations. All these kinds of things you can start with the synthetic data. Submit for verification. If the verification answer comes back, yes, good. The user's happy. They're done. They can go and do their publish it, whatever that means. If not, though, then they can apply for access to the confidential data and get vetted, whatever the costs are that involves, right? Because any of you have ever tried to get access to like a research Census Bureau, well, now they're the Federal Statistical Research Data Centers. It used to be the Census Research Data Centers. You have to undergo a level 2 security check. I'm not sure why researchers are considered level 2 security risk, but we are for some reason. And you've got to write a proposal, and you've got to wait 6 months. And if you're a student, you can't, like, why do you want to wait 8 months, 9 months, 10 months to do your research? You're not going to do it, so forget it. You're going to do something else, right? So if we can get people access to the data as they could start, that's a good thing. If we can avoid them from having to do that, it's an even better thing. But even if they have to go to the secure environment, they haven't wasted their time, right? Do y'all have a research data center? So you're lucky, right? You can just go there. Once you get access approval, you can go there. But think about, I think there's on the order of 38 or 39 of these across the country. That means there's a lot of people that don't live anywhere near one of these things. And so, if they're really serious about their research, they might have to leave their family and go somewhere for a few weeks or months to do their research in the data center. They're going to want to be efficient. I mean, they are not going to want to waste time learning that there weren't enough cases to do their analysis, or learning that, this exploratory work, I didn't realize I needed to think about this for my modeling. So the more efficient they can be, the better. And not only that, for the whole system itself, it frees cycles for that would have been done for exploratory analysis for the final analyses, right? If you have a lot of people hitting this, the more you can push that outside the system, the better. So that's kind of the overall system that I've been working towards as part of my research. I know we started a little bit. How much? I have a few more slides, but I want to be respectful. We're good? Okay, let me show you this in action. I will do my best to do that in 5 minutes. So this was a project that I was involved with, the Office of Personnel Management, OPM, which is basically the Human Resources Department of the government. And they have a really cool longitudinal file. They have so much data. But the one that we worked is basically a snapshot every September 30th of who's in the government, federal government. And it's got all sorts of good stuff on them, like where they're working, what their salary is, what their step and grade are, and education and military service, and lots of really interesting stuff, right? And we wanted to create a synthetic version of this because I was going to say there's no public use file, but actually some of you may recall that some years back that BuzzFeed got a hold of these data and published them. So actually there is public versions of them unintentionally. But anyway. So we basically made this synthetic data set where we simulated careers of people, okay? We actually removed people that had guns because we just didn't want to go into that region of risks somehow. So we made this synthetic data set. I should say it's a sad story. I can tell it to you after. The data were never released. We got caught up in administration changes and people leaving and no director at OPM, and all those things just stretched out for like 2 years, and then so it was quite depressing actually. But the project I think was still pretty cool. So what we've done here, we made the synthetic data set, and then what we want to do is see, let's do an illustrative analysis. Let's do a regression where we regress log basic pay per employee year on demographics, including race and gender. And what we're really interested in is there evidence in the federal government that pay is differing by some of these demographic variables, particularly race and gender. Okay? Here's the synthetic data results. This is based on the synthetic data, and I won't go through them in too much detail. This is some of the variables. A couple of things to sort of point out that were a little bit surprising to us from the synthetic data. One is here. White is the baseline, right? So for the males, like everybody, pretty much, well, maybe not American Indian, Alaska Native, but everybody was all the racial groups were lower than white. And we were particularly surprised that that's not something we'd read about in the literature. Here there's no differences, very little differences among the women. They're much smaller. Okay, but so the question is, okay, this is synthetic data. Are these results holding up? right? Maybe we just did a crappy job synthesizing. So let's see. So what we did then is built a verification measure, and I'm not going to describe this in much detail in the interest of time. But basically the idea is we talked to our legal friends, and they said, you know what, if you had like a 1%, if you like a minus 0.01 on that log coefficient in front of any one of those dummy variables on this log regression, like a 1% difference, that would be actionable. Like we would bring that to court. Okay, and so we said, all right, is the true coefficient, for Asian male less than minus 0.01? That might be a question we want to ask. Or is the true coefficient within a tolerance of the synthetic estimate? Kind of a similar idea. Okay, and so we created a verification measure, which basically you could think of. It's not quite this, but for our purposes, think of it as basically a posterior probability that the coefficient is less than minus 0.01. Okay, and so if you get a large value of this R, you conclude it is less than minus 0.01. You get a small value, you conclude it's not. For those of you who are curious, this actually satisfied differential privacy. This verification measure was a differentially private verification measure. For those of you who don't know what that means, that's okay. It tries to bound the amount of leakage from providing this feedback measure. That's what it's doing. So you can see that this thing actually did a pretty good job, right? This is the verification measure in the middle in bold. Synthetic data results on your left, confidential data results on your right. And you can see that pretty much all the confidential data results kind of mimic the trend more or less of the synthetic data results. We saw there's negative slopes, and all the verification measures suggest that too. Right? So if somebody just had verification, they would get the right answer, at least substantively. I mean, the estimates themselves are different, no question. But substantively, they would get the right answer. Okay? It is less than minus 0.01. And then for the female, again, with the confidential data results, you saw Asian is interesting. Oops, wrong one. Asian is interesting, right? I mean, we saw here is like, is it less than minus 0.01? I don't know. It's kind of on the borderline. Oops, sorry for that. And in the truth, it's actually right at minus 0.01. So getting a 0.42 is actually about right. Like, I'm not sure. Maybe it is, maybe it's not. Right? And with the coefficient for black, in the synthetic data, it was really, really small. In the confidential data, it's also really, really small. So this thing should be really, really small. Right? It's definitely not less than minus 0.01. Right? So again, the verification measure is kind of giving you the right answer. So we found that to be quite encouraging. Okay, so let me conclude then, so that I can open the floor for questions. This notion of synthetic data plus verification is actually being taken up. Actually, it's being taken up with a slight variation on verification, something called validation. Okay, and this is rather than getting a measure of how similar the results are, they give you a noisy measure of the results from the confidential data themselves. Okay, so give you those regression coefficients rather than the similarity measure. So it's a cousin, in my opinion. The statistics of income division, they're actually currently trying to make a synthetic tax file. There's no public use tax file. Well, actually, there's a high earners public use tax file. Another re-identification example, some of you may remember some years back when a reporter found President Trump's information in the, had some secret information about some of the values, and then found that record that matched those values, and then said, there's President Trump in the tax file. So another example of a re-identification, right? Anonymization is not enough. Anyway, they're making a synthetic tax file, and they're going to allow validation. The Census Bureau has been doing this. That longitudinal business database I mentioned, that's what they do. You can start with the LBD and submit your code to Census Bureau. They'll run it on the real data, make sure there's no disclosures, and pass it back to you. Same with the synthetic SIP. So this idea is actually happening. I'm actually going to talk to National Center for Health Statistics. They're going to try this too. If you're curious about the OPM example, it's in this paper right here. Thanks very much. I'm glad to take some questions.
Thank you very much for the talk. We've had some questions flow in through Slido over the course of the talk, and we will hit some of the highlights now. Yes, if you still have questions and have not submitted them, go to slido.com and enter that code. You should be able to submit more questions. Okay, so we'll start with this first one. How do you think social science research would change if we did not have access to public use record level data?
Ooh, wow. How would social science access change if we did not have access to public use record level data? I think it would be damaged. Well, assuming nothing else changes, I think it would be damaged, right? Many people download the public use files from the American Community Survey, or data files from the National Center for Education Statistics, or data files, the Survey Income and Program Participation, Health and Retirement Survey. That's not a government agency, but still a data set. And if we didn't have all these files, I think that would be pretty tough. Now, you could say, well, just everybody has to get agreements. And for some data sets, that may be feasible. Certainly if you want to access ad health or something like that, you can get agreements to access ad health data, right? But right now, at least with current laws, and they would have to change, you can't do that with a lot of government data sets. And so you have to go through these FSRDCs, which involves that whole process. And then the other thing, too, that I worry about, and it kind of comes back to that second slide, I think with a small d, being democratic about data access is a good thing. The more people we can bring to data, to problems, the better our solutions are going to be. And if we cut off students, cut off the public from data, I just think we'll lose off. So I think it would change a lot, and not for the better.
All right, our next question is, can synthetic data lead to new discoveries? So like if synthetic data
Good question.
The synthetic data generation model has missed an important covariant.
Yeah.
Remodeling the synthetic data finds that covariant.
Probably not. So can synthetic data lead to new discoveries? So yes and no, okay? So I'll do the no first. The no in the sense that whatever's in the synthesis model is possible to see in the analysis. So it's true. If I am not modeling a relationship and there's not enough information from the rest of the variables to kind of, get that relationship in the data, then I'm not going to see it. I'm not going to see it in the synthetic data. On the other hand, yes, in the following sense, a lot of the synthesizers that are being developed now are sort of non-parametric, right? Regression trees, deep learning, all kinds of cool stuff, right? And so you have these really, or Bayesian non-parametric models. You have these really complicated models. Well, trees are kind of easy to understand, but the rest of these things are not so easy to understand, right? And so, but if you can use them, so if you just give somebody the model, they're going to be like, I don't know, what is this thing? I have no idea what you're giving me. But if you can generate data from it, and then somebody can cleverly decide what to look at. So somebody decides, oh, what's really interesting is group A versus group B on this variable. That's the thing we need to look at, right? And the model, if it can capture that relationship, and then somebody decides this is what I need to look at. So I think, yes, that kind of new learning can happen. And again, I will emphasize too, in this vision, the synthetic data, it can be used for as a start, right? And you still can get validation, verification, or remote access.
All right, our next question is another question about the synthetic
Yeah.
data generation model. And it's about the release of it. So will releasing the synthetic data generation model leak sensitive information?
Good question. So does releasing the model leak sensitive information? Yes. But it partly depends on what that means, right? Releasing the model. So, for example, if I just say things like, well, to make this variable, like I was going to do, but then in the interest of time decided not to do, I made this variable by using a regression tree. And that's how I synthesized this one. And I included all these other predictors. That's how I made the model. I don't know if that releases anything. It just says these variables are in your data set, right? Which presumably is not a disclosure. On the other hand, if I release sort of like the specific parameter estimates and maybe they are affected. Maybe there's an outlier who's really moved things around. It's possible that there could be some disclosure from that. One other thing that I'll say here, with one of my former students, Robin Mitra, one thing we tried to do was we said, one thing I didn't mention, how this connects to multiple imputation, Professor Clogg, there's a connection here to Professor Clogg's work. One thing that there's a connection here is that when this was originally proposed by Rubin, it was to create multiple data sets, multiple imputations. And the idea was if you just release one and the user analyzes it, he won't really know if how much of his result is due to the randomness of generating. Like if you do it a second time, you could get a totally different data set and maybe a different answer. So if you release multiple data sets, kind of like multiple imputation for missing data, you can propagate that uncertainty through various combining rule formulas. So anyway, what we did was we said, well, what if you released m equals 3? What if you did m equals 10? What if you did m equals 50? And we could try to compute probabilities of re-identification. And we did see that with the more data sets, those risks did tick up. Not massively, but they did tick up. Mm-hmm. So yes is the answer. I should have just said yes.
So before I ask this next question, to clarify, you don't release the data generated model.
We release a description of the model, but we don't provide a piece of code that could be run. Well, actually, that's not quite true. So we were somewhere in between. With the LBD, I'm trying to remember with the synthetic LBD, we actually did release the code, but we didn't release the parameters of the code, right? So we released the code, and if there was any, data numbers that were in there, like, if this person has an income above X, then use this model. If it's below X, then use that model. Like, we wouldn't release those X's.
So a follow-up to that question. Oh, sorry. This is Slido.
Great.
So what would the advantage of analyzing synthesized records be rather than just looking at the parameterization of the simulation model, if that is accessible?
Yeah, so what would the advantage of analyzing synthetic data as opposed to just having the model? So some of it comes down to that last group in particular, and maybe all the groups, but really that last group that I was talking about, the benefits of data access to the public. Like a lot of analyses of public use data files are comparisons of means and percentages and regressions and correlations. That's like 90% of analyses, just I'm pulling that number out of nowhere, but there's a lot of, not everybody is doing, Heckman selection model, Tobit, this, that, those are wonderful, but people, if they just get a bunch of parameters from a model and they're trained to take data and compute differences in means and confidence intervals, it's not going to be so easy for them to back those out from the model. So it's really about making life easier for the people who are going to use the data. And that's what a lot of this is all about.
Yeah, our follow-up question, so is synthetic data better at protecting the confidentiality of outliers, such as your Bill Gates example, than other data privacy methods?
That's a great question. Is synthetic data better at protecting outliers? Gosh, it's hard to answer that question because a lot depends on how you do the synthesis model, of course, right? I mean, if my synthesis model is a bootstrap of the original data, it's not going to do any kind of protection, right? But that is technically a synthesis model. No one would ever do that, but technically that is, right? On the other hand, if my synthesis model is the data are, sure there's a skew, but I'm just going to pretend it's normal and I'll never get out there, maybe it'd be just fine. And so a lot depends on the model that's being used. I will say a couple things. Outliers are tough no matter what you're doing. It doesn't matter whether it's synthetic data, noise, differential private algorithms, aggregation. Outliers are tough, right? Because they matter. Like take the business one, the business LBD. Everybody knows there is a large airplane manufacturer in Washington, right? And there's no question about that. We don't want to call that a disclosure. So what? You found that out. You knew that already. but how many people, well, you could probably go look up in their financial reports, but let's ignore that. We're not allowed to release how many people they employ or what their payroll is. And those are obviously way out there compared to the other industries in Washington in the airline sector. Because there are more, right? There's all the little companies that provide the other stuff. Way out there. And honestly, our synthesis models, we had a hard time getting out there, right? I mean, we had a hard time building a model that was able to synthesize values out there. And that's some of the reason why I think you see some of those misses, because of those big outliers being not quite hit. And we looked very carefully at them in the disclosure. We looked, I mean, it's like a utility and disclosure. They're kind of two sides of the same coin sometimes. Right? You can sometimes when you look at a utility measure, like if you have worse utility, like we missed the outliers, sometimes that gave us better disclosure, right? So we looked at them, and our synthesis models were like, they wouldn't get out there very, very often. Census Bureau was comfortable enough with it, but it's a utility cost. So I guess the answer, better than other methods, I don't think I could want to put my name next to that broad statement. I think just they all struggle, and with the really massive ones. If it's just a skewed distribution, I think synthetic data is fine.
All right, well, go ahead and conclude with our final question here. And it's, how do you expect the synthetic data landscape to change over the next 10 to 20 years?
Woo, that's a great question. How does it change over the next 10 to 20 years? There's a lot of open research problems, honestly. So let me say a few of them. So one of them is assessing the disclosure risk. Okay, I mentioned it's low, but honestly, we don't have a great way of assessing. I mean, we have ways. We've written about them, but they're all illustrated on toy examples. Like doing it on the synthetic LBD with its hundreds of variables, that's not so easy. Computationally, like setting up the model, just thinking that through. I mean, we compute Bayesian posterior probabilities of the true value being within some range given the synthetic data that's released. That's kind of the basic idea, and maybe relative to some prior beliefs, what you can learn, with the point, without the point, like various manifestations like this. But actually computing those probabilities is tough. So I think there's, I just got an SF grant to do that, but I think that's going to be an important, of course, I think it's going to be an important area to try to figure out, that out. I think really interesting is going to be looking at differential privacy and formal privacy and how that is going to intersect with synthetic data. The original differential privacy was originally around query systems mostly. Like you query a system, you get back a noisy answer. That's how it was, mostly conceived. But I think there's been a realization among computer science community that synthetic data, just basically, again, made up, simulated data from some model, but now a model that's been protected from some formally private way, like differential privacy, that could be really appealing. But right now, it's really hard to do. Again, for small type data sets, like the census is small. I mean, it's a lot of records, but in terms of the number of variables, it's not that many. And that was a job, right? I mean, you all have read all the controversy about that and the lawsuits, and they did a remarkable job. I mean, they are further on the edge than Apple and Google and all those places. I mean, they are the cutting edge right now in differential privacy. It's remarkable. It's the Census Bureau. It's awesome. But doing that for like hundreds of variables and with survey weights, we don't know how to do that with survey weights. We have no idea how to get survey weights. Editing, imputation, no idea how to get that into this process. There's a lot of work to be done there, I would say. So I think there's a lot of research that's going to happen. I think it's going to be, more and more. It's going to be more and more prevalent. I think a lot more organizations are considering it. There are startup companies popping up all over the place. Like just look. You'll see, if you do a quick search, you'll see synthetic data startup companies. They're building synthetic data to train AI algorithms. I mean, it's just kind of going everywhere now. And so I think it will become a bigger part of the future, but I think there's a lot of opportunity for research.
Great.
With that, please join me.
Thank you.